Hello, in this lecture we will find out the length of chord AB. In the drawing we have a semicircle. Inside this semicircle we have two small circles. Those two small circles are identical, and in the middle we have the middle circle, and the middle circle is tangent to the semicircle at point O, and point O is also the center of the middle circle. And point C is point O is the center of the semicircle. Okay? Point O is the center of the semicircle, while point C is the center of this middle circle. And we also know that PQ equals to 8 units. So PQ, it is actually the diameter of this semicircle, and the diameter of any circle is twice as large as the radius. Therefore, the radius of this semicircle will be equal half of the diameter, that is to say it will be equal to 8 over 2, so it equals to 4 units. So the radius of this semicircle PO equals to 4 units, and the radius OQ of this semicircle will be also equal to 4 units. Likewise, the radius OX of this semicircle will be equal to 4 units. But OX is not only the radius of this semicircle, but it is also the diameter of this middle circle. So we know that the diameter of this middle circle equals to 4 units, because OX equals to 4 units. Therefore, the radius of this middle circle will be equal to half of it. That is to say, it will be equal to 4 over 2 units. That is to say, the radius of this middle circle will be equal to 2 units, and OC, that is the radius of this middle circle, will be also equal to 2 units. Okay, we will define the center of this small circle as point M. Then we will join together points M and C by a straight line. Actually, MC, M is the center of the small circle, and C is the center of the middle circle, and MC is the distance between the centers of those two circles, and MC, because of the fact that those two circles have external length between them, the touching point between them is at this point. We'll define this point as point Y. So those two circles have an external length between them, and the distance between the centers of two circles that have an external length between them will be equal to the distance between their radiuses, or to the sum of the length of their radiuses. And if my is the radius of this small circle, we will define it as r. So the distance my is r units, and yc, that is the radius of this middle circle, it equals to 2 units, because the radius of this middle circle equals to 2 units. So in total, the distance MC equals to r plus 2. Okay? in the next step, we will define the touching point between tangent PQ and this small circle. This point we will define it as point N. Point N, it is actually the point of tangency between tangent PQ and this small circle. Then we will connect together points M and N by a straight line. MN is the radius of this small circle, that is to say it equals to R. And here we have the radius MN of this small circle. It is drawn to the point of tangency, that is to say it is drawn to point N, that is the point of tangency of point P of tangent PQ with this small circle. Therefore, the tangent PQ will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Likewise, the radius CO of this middle circle is drawn to the point of tangency, that is to say it is drawn to point O, that is the point of tangency of tangent PQ with this middle circle. Therefore, the tangent PQ will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? In the next step, I will draw perpendicular from point M to CO. So here this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees because we have the perpendicular from point M to CO. And we will define the touching point between the perpendicular from point M to CO as point D, and we will also define this point as point E. And I will draw again the quadrilateral MNOD, this quadrilateral, and the right triangle CMD. Okay? So I draw again the quadrilateral MNDO and the right triangle, triangle CDM. We also know that AB is parallel to PQ. Okay, AB is parallel to PQ. Okay, again, AB is parallel to PQ, and I present to you again AB is parallel to PQ. In the next step, I will present to you a new rule, rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. So I'll read rule number 1 again. According to rule number 1, corresponding angles between parallel lines are equal to each other. It is given us the question that AB is parallel to PQ, and we have those two angles are defined as corresponding angles. That is to say, this angle that equals to 90 degrees is a corresponding angle, and it equals to this angle that is actually angle CEB. Okay, according to rule number 1, those two corresponding angles that are located between the parallel lines AB and PQ are equal to each other. So this angle equals to 90 degrees, and it equals to this angle that is actually angle CEB. This angle is angle CEB, and it equals to this angle that is 90 degrees. So in total, we found out that according to rule number 1, this angle that is actually angle CEB equals to this angle that is actually 90 degrees. Or that is to say, angle CEB equals to 90 degrees according to rule number 1. Okay, angle CEB equals to 90 degrees according to rule number 1. Why? Because those two corresponding angles, angle CEB and this angle that equals to 90 degrees, are located between the parallel lines AB and PQ. Therefore, according to rule number 1, they are equal to each other. That is to say, angle CEB equals to 90 degrees. So angle CEB equals to 90 degrees according to rule number 1. So this angle is a right angle according to rule number 1. Likewise, we have those two angles, they are located between the parallel lines AB and PQ. Okay, so this angle that is actually angle CEB will be equal to this angle that is actually angle that equals to 90 degrees, because of the fact that those two angles are located between the parallel lines AB and PQ, and the corresponding angles that are located between parallel lines are equal to each other according to rule number 1. So this angle, so angle CEY will be equal to this angle that is actually equals to 90 degrees. Or in other words, according to rule number 1, angle CEY equals to 90 degrees. So this angle CEY equals to 90 degrees, that is to say it is a right angle. So this angle is a right angle. Okay? According to rule number 1, because it is located between the parallel lines AB and PQ. So those two angles are equal to each other. So if this angle equals to 90 degrees, then this angle will be also equal to 90 degrees. Okay? So in the next step, we will focus on quadrilateral MNOD, this quadrilateral. And we actually have also rule number 2. According to rule number 2, the sum of the angles in any quadrilateral equals to 360 degrees. The sum of the angles in any quadrilateral equals to 360 degrees. Okay, so I will read rule number 2 again. According to rule number 2, the sum of the angles in any quadrilateral equals to 360 degrees. And especially in quadrilateral MNOD, the sum of its angles equals to 360 degrees according to this rule number 2. So this quadrilateral MNOD has 3 right angles, 1, 2, 3, and the sum of those 3 right angles is equal to 290 times 3 is 270 degrees. So in quadrilateral MNOD, we have three angles that the sum of them is 270 degrees plus this angle that we will define as angle x. So the sum of those four angles must be equal to 360 degrees according to rule number 2. Okay, so here in quadrilateral MNOQ we have three right angles that the sum of them is 270 degrees plus the size of the fourth angle that is actually angle x. In total they must be equal to 360 degrees according to this rule number 2. So here we will subtract 270 degrees from this equality and we will get that angle x equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle x is a right angle, it equals to 90 degrees. So we can change x to 90 degrees. This angle is a right angle, it equals to 90 degrees. So you can see from in the drawing that all four angles of quadrilateral MNOP and MNOD are right angles. It has four right angles. Okay, and we also have rule number 3. According to rule number 3, any quadrilateral that has four right angles must be at least a rectangle if not a square. If not a square, it must be a rectangle. I read rule number 3 again. According to rule number 3, any quadrilateral that has four right angles must be at least a rectangle, if not a square. So here, quadrilateral MNOD has four right angles. Therefore, we relate to quadrilateral MNOD, this quadrilateral, as a rectangle. Okay? So, what is the value of CO? CO, here, CO, here, CO, it is actually the radius of the middle circle. You can see here that CO is the radius of the middle circle, that is to say it equals to 2 units. So we can write here that CO equals to 2 units because it is the radius of the middle circle. It equals to 2 units. And we also have rule number 4. According to rule number 4, according to rule number 4, the opposite sides of a rectangle are equal to each other. I repeat again on rule number 4. According to rule number 4, the opposite sides of a rectangle are equal to each other. So here, the opposite sides of this rectangle are equal to each other. That is to say, MN equals to DO and MD equals to NO. But what is the value of MN? From the drawing, from the original drawing, you can see that MN is the radius of the small circle, that is to say MN equals to R. MN equals to R, it is the radius of the small circle. But according to rule number 4, MN also equals to DO. Okay, according to rule number 4, MN equals to DO. I'll repeat again. MN equals to DO according to rule number 4. But we know also that MN equals to R. It is the radius of the same circle. MN equals to R. So from this equality, we will conclude that DO equals to R. DO equals to R. So here DO equals to R. And we also know that CO equals to 2 units. So CO minus DO equals to CD. Again, CO minus DO equals to CD. I will write it down. From the drawing you can see that CO minus DO equals to CD. Okay? But we know that CO equals to 2 units. This is the radius of the middle circle, and DO equals to R. It is the radius of the small circle. So in total, we found out that CD equals to 2 minus R. CD equals to 2 minus R. So you can write here that CD, this line segment CD, equals to 2 minus R. Okay? And we have already found out that MC, that is the distance between the centers of the small circle and the middle circle, it equals to R plus 2. MC equals to R plus 2. You can see from the original drawing, you can see that MC equals to R plus 2 because MY is the radius of the small circle and 2 the radius of the middle circle equals to 2 units. So in total MC equals to R plus 2. Okay, so MC equals to R plus 2 and CD equals to 2 minus R. MC equals to 2 minus R. So we will focus on the right triangle CDM. This right triangle CDM. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. And the hypotenuse in the right triangle CDM is CM. So the square of the hypotenuse is CM square, and it equals to the sum of the squares of the perpendiculars. It equals to CD square plus MD square. Okay, plus MD square. So I will repeat again. In the right triangle CDM, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, and the hypotenuse is CM, so the square of the hypotenuse is CM square. It equals to the sum of the squares of the perpendiculars. That is to say, it equals to CD square plus MD square. Okay, but we have already found out that Cm equals to R plus 2, therefore Cm square will be equal to R plus 2 square, and it equals to CD square. CD equals to 2 minus R, so CD square will be equal to 2 minus R square plus MD square. So in total we found out that Cm square is R plus 2 square, CD square is 2 minus R square. So R plus 2 square equals to 2 minus R square plus MD square. Here we will open the brackets in both sides of this equation, equation number 2, and we will get that R plus 2 square is R square plus 4 plus 4R. And 2 minus R square is 4 plus R square minus 4R plus MD square. Here we have R square on both sides of equation number 1, so R square will get cancelled. And we have also 4 on both sides of equation number 1, so 4 will also get cancelled. And what is left after we cancel those expressions in equation number 1? What is left from equation number 1? In this side of equation number 1, only 4R is left. 4R. And on the other side of equation number 1, what is left? It is actually minus 4R plus MD square. Okay? So, in total we got that 4R equals to minus 4R plus MD square. Here we will add 4R to this equation, equation number 1, and we will get that 4R plus 4R is 8R. equals to 4r minus 4r is 0, and so what is left here is only md squared. So we got that 8r equals to md squared. Here we will take a root out of equation number 1, and we will get that md equals to the square root of 8r. Okay? So we got that md equals to the square root of 8r. 8 is 4 times 2, so we will substitute 8 by 4 times 2 in this equation, equation number 1. And we will get that md equals to the square root of 4 times 2 times r. Okay, md equals to the square root of 4 times 2 times r. The square root of 4 is 2, so I will write it down. In total we will get that md equals to 2 times square root of 2r. Okay, I found out that md equals to 2 times square root of 2r, so we can write here that md equals to 2 times square root of 2r. And we have also rule number 4 that states that the opposite sides of a rectangle are equal to each other. That is to say, MD equals to NO. MD equals to NO. According to rule number 4, if we relate to quadrilateral MNDO, MD equals to NO. According to equation, rule number 4, MD equals to NO, according to rule number 4, but we have already found out that MD equals to 2 times square root of 2R. So from this equality, we will conclude that NO also equals to 2 times square root of 2R. NO equals to 2 times square root of 2R. Okay, here NO also equals to 2 times square root of 2R. In the next step, we will connect points M and O by a straight line. We will do the same thing in the original drawing. We will connect points M and O by a straight line. And we will also connect together points A and M by a straight line. What is AM? AM, it is actually the radius of this small circle, that is to say it equals to R. So AM equals to R. What is the value of OA? 08 is the radius of the semicircle, that is to say it equals to 4 units. OA equals to 4 units. So MO, you can see from the drawing that MO equals to AO minus AM. Again, AO minus AM equals to MO. MO equals to AO minus AM. MO equals to AO minus AM. I will repeat again, MO equals to AO minus AM. But we have already found out that AO equals to 4 units and AM equals to R, so in total we will get that MO equals to 4 minus R. So we found out that MO equals to 4 minus R. So we can write here that MO equals to 4 minus R. Okay, MO equals to 4 minus R. In the next step we will focus on the right triangle, triangle MNO. This right great triangle, triangle MNO. Okay, we'll focus on the great right triangle. Triangle MNO. So, according to the Pythagoras theorem, in the right triangle, triangle MNO, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the green right triangle is MO, so the square of the hypotenuse is MO squared, and it equals to the sum of the squares of the perpendiculars, that is to say it equals to MN squared plus NO squared plus NO squared. So, in the right green triangle, triangle MNO, according to the Pythagoras theorem, MO square equals to MN square plus NO square. But we have already found out that MN equals to 4 minus R. So, if MN is equals to 4 minus R, it is actually MO. MO equals to 4 minus R. So if MO equals to 4 minus R, then MO squared will be equal to 4 minus R squared. So it equals to 4 minus R squared. MO squared is 4 minus R squared. Again, MO square is 4 minus R square. And MN equals to R, so MN square is R square plus NO square. NO equals to 2 times square root of 2R, so NO square will be equal to 2 times square root of 2R square. 2 times square root of 2R square. So in total we got that MO square is 4 minus R square, MN square is R square, and NO square is 2 times square root 2R square. In total 4 minus R square equals to R square plus 2 times square root of 2R square. Here we will open the brackets on both sides of equation number 2, and we will get that 4 minus R square is 16 plus R square minus 8R, and it equals to R square plus the square of 2 times square root of 2R is 2 square is 4, and the square of root 2R is 2R, and 4 times 2 is 8, so in total we got that this expression equals to 8R. So here we have R square in both sides of equation number 2, so R square will get cancelled. We will add 8R to this expression, equation number 2, and we will get that (16) plus 8R minus 8R is 16, and here we have 8R plus 8R is 16R. So in total we got that 16 equals to 16R. We will divide this equation number 2 by 16, and we will get that R equals to 1 unit. 16 minus 16 is 1, so R equals to 1 unit. So we found out that the radius of the small circle equals to 1 unit. So here R equals to 1, and here also R equals to 1, and CD equals to 2 minus R, and R is 1, so CD equals to 2 minus 1, that is to say CD equals to 1 unit. CD equals to 1 unit. So in the next step we will focus on the right triangle CEY, the green right triangle CEY, and on the right triangle CDM, and we will prove this triangle CDM, and we will prove that those two right triangles are similar to each other. So we will focus on triangle CY, the green triangle, and the right triangle CDM. In those two triangles, those two angles are equal to each other, they are both right angles. Okay, so here this angle is angle CEY, in triangle CY equals to this angle is angle CDN in triangle CDN, and both angles are right angles, that is to say they are equal to 90 degrees. So angle CEY equals to angle CDN equals to 90 degrees. And we also know that this angle, angle C, is a common angle. Angle C, this angle belongs to the green triangle, and angle C also belongs to triangle CDM. So angle C is a common angle, so we can write down that angle C equals to angle C is a common angle that belongs to both triangles. I repeat again, angle C equals to angle C, it is a common angle that belongs to both triangles. And finally, those two angles are equal to each other according to third angle theorem. That is to say, this angle is angle CYE, angle CYE equals to this angle, so angle CYE is the angle of the green triangle, CYE, and angle CMD belongs to triangle CDM, this angle. Angle CMD, this angle equals to angle CYE of triangle CYE. And they are equal to each other, those two angles are equal to each other according to third angle theorem. I will repeat again, angle CYE equals to angle CMD according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the first pair of angles must also congruent. And here we actually proved that those two angles congruent. So this is the first pair of angles that congruent, and this angle equals to itself. So this is the second pair of angles that congruent in those two triangles. So we have in those two triangles two pairs of angles that congruent to each other. So in this case, if this is the case, that we have two pairs of angles that congruent in two triangles, then the third pair of angles must also congruent. Those two angles must also congruent. Those are the first pair of angles, and they must also congruent. That is to say, angle CYE must be, in triangle CYE, must be equal to angle CMD of triangle CDM. Okay? So those two angles congruent to each other according to third angle theorem. So we actually proved that all three angles 1, 2, 3 of triangle CYE congruent to all three angles 1, 2, 3 of triangle CDM. Therefore, we actually proved that triangle CYE is similar to triangle CDM according to angle similarity rule. So I will write it down. We actually proved the triangle CYE is similar, this is the sign of similar, to triangle CDM according to angle similarity rule. I will repeat again. We actually proved that the right triangle CYE, the right green triangle CYE is similar to triangle CDM according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle can grant to all three angles in another triangle, then you actually proved that those two triangles are similar to each other according to angle similarity rule. And from the fact that triangle CYE is similar to triangle CDM, we will conclude that the following equality is true. We will conclude that CE over CY in the green triangle equals to CD over CM in triangle CDM. So I write it down. We will conclude that CE over CY in triangle CYE equals to CD over CM in triangle CDM. Okay? CE over CY in triangle CYE equals to CD over CM in triangle CDM. So CE over CY. What is the value of CY? You can see in the original drawing that CY here, CYE, CY is the radius of the middle circle, that is to say it equals to 2 units. So CY equals to 2 units and it equals to CD over CM. What is the value of CD? From this drawing you can see that CD equals to 1 unit. CD equals to 1 unit. So we can write down that CD equals to 1. And what is the value of CM? From this drawing you can see that CM equals to R plus 2 and R equals to 1. So in total CM equals to 1 plus 2, that is to say CM equals to 3 units. So CM equals to 3. So in total we found out that CE over 2 equals to 1 over 3. Here we will multiply equation number 3 by 2 and we will get that CE equals to 2/3. So we found out that CE equals to 2/3. So we can write here that CE, this line segment CE equals to 2/3. CE equals to 2/3. This line segment here. And what is the value of DE? From the drawing you can see that DE equals to CD minus CE. Okay? You can see from the drawing that DE, this line segment DE equals to CD minus CE. I will repeat again. From the drawing you can see that DE equals to CD minus CE, but we know that CD equals to 1 unit, CD equals to 1 unit, and CE equals to 2/3. So we can write down that DE equals to 1 minus 2/3. That is to say DE equals to third. DE equals to third. So we can write here that DE equals to 1 over 3 equals to third. Okay? And in the next step we will join together points O and B by a straight line. What is OB? OB is the radius of the semicircle, that is to say it equals to 4 units. And what is the value of OE? From this drawing you can see that OE equals to OD plus DE. Again, OD plus DE equals to OE. OE equals to OD plus DE. I'll repeat again. OE equals to OD plus DE. But we have already found out that we know that OD equals to 1 unit. OD equals to 1 unit, and we have already found out that DE equals to third. So in total OE equals to 1 plus third. 1 plus third is 4/3. OE equals to 4 over 3 units. Okay, here OE equals to 1 plus third, that is to say OE equals to 4 over 3 units. So we can write here that OE equals to 4 over 3 units. So here we join together points O and B by a straight line. OB is the radius of the semicircle, that is to say it equals to 4 units. In the next step we will calculate the value of this angle. We will calculate the value of angle OED. We will calculate the value of angle OEB. This angle is angle OEB, and we will find out the size of this angle OEB. We will find out the size of angle OEB. Here we will find out the size of this angle OEB. Okay. We also actually have a new rule number 5. According to rule number 5, the sum of the angles on one side of a straight line equals 280 degrees. I will read rule number 5 again. According to rule number 5, the sum of the angles on one side of a straight line equals 280 degrees. So here CO is the radius of the middle circle. Here you can see that CO is the radius of the middle circle. Therefore, it is absolutely a straight line. So CO is a straight line. And if you focus on this side of the straight line CO, according to rule number 5, at point E, the sum of its angles must be equal to 180 degrees. Which angles we have at point E on this side of the straight line CO? The angles that we have at point E on this side of the straight line CO, we have here, this angle is 90 degrees, it is a right angle, plus this angle is angle O, this angle, it is actually angle OEB, plus angle OEB, this angle is angle OEB. In total, those two angles, the sum of those two angles must be equal to 180 degrees, according to rule number 5, that says that the sum of the angles on one side of the straight line equals to 180 degrees. So if you focus on this side of the straight line CO at point E, the sum of the angles must be equal to 180 degrees. So this angle is 90 degrees and this angle is angle OEB. So the sum of those two angles, 90 degrees plus the size of angle OEB, must be equal to 180 degrees according to rule number 5. Here we will subtract 90 degrees from this equality and we will get that angle OEB equals to 180 degrees minus 90 degrees, angle OEB equals to 90 degrees. So we found out that this angle OEB, is a right angle, that is to say it equals to 90 degrees. So here we'll join points O and B by a straight line. So you can see here that because of the fact that this angle OEB, is a right angle, then triangle OEB, this triangle is a right triangle. Okay, so I will draw again the right triangle OEB and we will find out the length of side EB. Okay, so here we have the right triangle OEB. I will draw it again in a new page. So I draw again the right triangle OEB. We know that OB is the radius of the semicircle, that is to say it equals to 4 units, and we already found out that OE equals to 4 over 3 units. And we will find out the length of side EB. We will find out the length of side EB according to the Pythagoras theorem. That the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle OEB is OB, so the square of the hypotenuse is OB square. And it equals to the sum of the squares of the perpendiculars, that is to say it equals to EB square plus OE square. So I'll repeat again. In the right triangle OEB, according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OB, so the square of the hypotenuse is OB square. It equals to EB square plus OE square. Okay? We know that OB equals to 4 units, so OB square is 4 square. 4 square is 16. It equals to EB square. EB square is EB square plus OE square. OE equals to 4 over 3, so OE square is 4 over 3 square. So in total we got that OB square is 16 because it is 4 square. EB square is EB square. And OE equals to 4 over 3, so OB square is 4 over 3 square. 4 over 3 square is 16 over 9, so I will write it down. And we will get that 16 equals to EB square plus, here 4 over 3 square is 16 over 9. Here we will subtract 16 over 9 from this equation number 4, and we will get that 16 minus 16 over 9 equals to EB square. Here we will multiply 16 by 9 and then we will divide it by 9 in order to have a common factor with 16 over 9, and we will get that 16 times 9 over 9 minus 16 equals to EB square. So here 16 times 9 minus 16 is 16 times 8, so I write it down. So 16 times 9 over 9, 16 times 8 over 9 equals to EB square. So we got that 16 times 9 over 8 equals to EB square. 16 is 8 times 2, so we will substitute 16 by 8 times 2. And we will get that according to equation number 4, 2 times 8 times 8 over 9 equals to EB squared. So here we will take a root out of this equation, equation number 4, and we will get that EB equals to the square root of 2 times 8 times 8 over 9. And the square root of 8 times 8 is 8, and the square root of 9 is 3. So I write it down. In total we will get that EB equals to 8 over 3 times square root of 2 units. So we found out the value of EB. EB equals to 8 over 3 times square root of 2 units. Okay, so in the next step we will prove that those two right triangles can go into each other. We will prove that the right green triangle, triangle OEB, can go into the right green triangle, triangle OEA. So I will draw again those two right triangles, and we will prove that they can go into each other. Okay. So we will prove that those two triangles can go into each other. First of all, we know that OA, AO equals to BO equals to 4 units. They are actually the radiuses of the semicircle, so we write down that OA equals to OB equals to 4 units. And we also know that OE is a common side, it belongs to both triangles. So we will write down that OE equals to OE is a common side that belongs to both triangles. OE equals to OE, it is a common side that belongs to both triangles. So by proving those two things, we actually proved the triangle OEA is congruent to triangle OEB according to rule number 6. Triangle OEA is congruent. This is the sign of congruent to triangle OEB according to rule number 6. Okay, triangle OEA congruent to triangle OEB according to rule number 6. So what is rule number 6? Rule number 6 states that if the hypotenuse and the perpendicular in one right triangle congruent to the hypotenuse and the perpendicular in another right triangle then the two right triangles congruent to each other. I will repeat again on rule number 6. According to rule number 6, if the hypotenuse and the perpendicular in one right triangle congruent to the hypotenuse and a perpendicular in another right triangle, then the two right triangles congruent to each other. And here we actually proved that those two triangles congruent to each other according to rule number 6. Why? Because we proved that the hypotenuse OB and the perpendicular OE in the right triangle OEB is congruent to the hypotenuse OA and the perpendicular OE in the right triangle OEA. Therefore, we proved that those two right triangles congruent to each other according to rule number 6. Okay? Because that is exactly what rule number 6 requires. It requires to prove that the hypotenuse and the perpendicular in one triangle congruent to the hypotenuse and the perpendicular in another right triangle. And this is exactly what we proved. Therefore, we proved that those two right triangles congruent to each other. And from the fact that those two right triangles congruent to each other, we will conclude that AE equals to EB. Okay, AE equals to EB. AE equals to EB. AE equals to EB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides AE and EB will be equal to each other, that is to say AE equals to EB. And what is the value of AB? From the drawing you can see that AB equals to AE plus EB. Okay, AB equals to AE plus EB. But we have already found out that AE equals to EB, so we can substitute AE by EB in this equality. So we'll do it and we will find out that AB equals to EB plus EB. That is to say AB equals to 2 times EB. But we have already found out that EB equals to 8 over 3 times square root of 2 units. So in total we found out that AB equals to 2 times 8 is 16. In total, AB equals to 16 over 3 times square root of 2 units. Or in terms of numbers, AB equals to 7.54 units. I will repeat again. We found out that chord AB equals to either 16 over 3 times square root of 2 units, or in terms of numbers, chord AB, the length of chord AB is 7.54 units. So here, in the drawing itself, the chord AB, the length of chord AB is either 16 over 3 times square root of 2 units, or in terms of numbers, chord AB, the length of chord AB equals to 7.54 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the length of chord AB. We have here a semicircle. Inside this semicircle we have 3 circles. Those two small circles are identical. In the middle we have the middle circle. This middle circle is tangent to at point O to PQ, which is tangent to the semicircle at point O, and point O is also the center of the middle circle, the center of the semicircle. Again, point O is the center of the semicircle, and point C is the center of the middle circle. We also know that PQ equals to 8 units. PQ is the diameter of the semicircle, and it equals to 8 units, and the diameter of any circle is twice as large as the radius. So if the diameter equals to 8 units, then the radius of the semicircle equals to 4 units. That is to say, PO, that is the radius of the semicircle, equals to 4 units, and OQ, that is also the radius of the semicircle, equals to 4 units. Likewise, OX, that is also the radius of the semicircle, equals to 4 units. But OX, it is not only the radius of this semicircle, but it is also the diameter of this middle circle. So the diameter OX of this middle circle equals to 4 units. Therefore, the radius of this middle circle will be equal to 2 units. That is to say, CX, that is the radius of the middle circle, equals to 2 units, and CO, that is also the radius of this middle circle, equals to 2 units. Likewise, CY, that is the radius of the middle circle, will also equal to 2 units. Then we also know that AB is parallel to PQ, and we join together points M and C by a straight line. MC is the distance between the centers of the small circle and the center of the middle circle, and the distance between two circles that have an external knot between them equals to the sum of the lengths of the radiuses. That is to say, MC will be equal to R, that is the radius of the small circle, plus 2, that is the length of the radius of the middle circle. So MC equals to R plus 2 units. Then we actually, from point N, we defined the touching point between tangent PQ and this small circle is point N. Then we join together points M and N by a straight line. MN is the radius of this small circle, and this radius is drawn to the point of tangency, that is to say it is drawn to point N, that is the point of tangency of tangent PQ with this small circle. Therefore, this tangent PQ will be perpendicular to this radius, MN. That is to say, this angle equals to 90 degrees and this angle will be also equal to 90 degrees. Likewise, we have the radius CO of the middle circle that is drawn to the point of tangency, that is to say, it is drawn to point O, that is the point of tangency of tangent PQ with this middle circle. And because of the fact that this radius is drawn to the point of tangency, PQ will be perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. In the next step, from point M, we draw perpendicular to CO. So this is perpendicular, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. And we define the touching point between the perpendicular from point M to CO as point D. Then we define this point as point E. And I draw again all the drawing before the semicircle. We have this, the quadrilateral MNOD and the right triangle CMD, and actually I presented to you rule number 1. We know that AB is parallel to PQ, and according to rule number 1, corresponding angles between parallel lines are equal to each other. So we know that AB is parallel to PQ, and those two angles, this angle and this angle, are defined as corresponding angles. Angle CEB and angle COQ are two corresponding angles that are located between the parallel lines AB and PQ, therefore they are equal to each other. This angle is a right angle, and this angle is angle CEB, that is to say, angle CEB equals to 90 degrees according to rule number 1. Okay? Because those two angles are corresponding angles that are located between the parallel lines AB and PQ. Therefore, according to rule number 1, they are equal to each other. That is to say, angle CB equals to 90 degrees. Likewise, we have those two angles that are located, that they are corresponding angles, and they are located between the parallel lines AB and PQ. Therefore, according to rule number 1, they are equal to each other. That is to say, this angle equals to this angle. This angle is right angle, it's equals to 90 degrees, and this angle is angle CEY. That is to say, angle CEY equals to 90 degrees according to rule number 1. Okay? Then I presented to you rule number 2. According to rule number 2, the sum of the angles in any quadrilateral equals to 360 degrees. If we focus on this quadrilateral MNOD, according to rule number 2, the sum of its angles must be equal to 360 degrees. This quadrilateral MNOD has 3 right angles, 1, 2, 3. The sum of 3 right angles is 90 times 3 is 270 degrees. So it has 3 angles that the sum of them is 270 degrees, plus the size of the 4th angle that is defined as angle X must be equal to 360 degrees according to this rule number 2. we subtracted 270 degrees from this equality, and we find out that angle x equals to 90 degrees. So we found out that this angle, it is a right angle, it equals to 90 degrees. Okay, so actually all four angles of quadrilateral MNOD are right angles. They are equal to 90 degrees. And we also have rule number 3 that states that any quadrilateral that has four right angles must be at least a rectangle, if not a square. And because of the fact that this quadrilateral MNOD has four right angles, it must be at least a rectangle. So we will relate to this quadrilateral as a rectangle. And we also have rule number 4 that states that the opposite sides of a rectangle are equal to each other. Okay? And we know that MN is the radius of the small circle. MN equals to R. So here we can write down that MN equals to R. It is the radius of the small circle. And we have rule number 4 that states that the opposite sides of a rectangle are equal to each other. That is to say, MN equals to DO. Again, according to rule number 4, MN equals to DO. But we know that MN equals to R. We know that MN equals to R. So from this equality, we will conclude that DO also equals to R. So DO equals to R. DO equals to R. And CO is the radius of the middle circle. CO is the radius of the middle circle, therefore it equals to 2 units. CO, as you can see, CO equals to 2 units. CO equals to 2 units. And DO equals to R. We've already found out that DO equals to R. What is the size of CD? CD equals to CO minus DO. CO minus DO equals to CD. You can see from the drawing that CO minus DO equals to CD. But we have already found out that CO equals to 2 and DO equals to R. So in total we found out that CD equals to 2 minus R. CD equals to 2 minus R. Here CD equals to 2 minus R. And what is the value of MC? MC, we have already found out that MC equals to R plus 2. Here, MC equals to R plus 2. Okay, MC equals to R plus 2 and CO and CD equals to 2 minus R. So we will focus on the right triangle CDM, this right triangle, and we will implement the Pythagoras theorem in the right triangle CDM. According to the Pythagoras theorem in the right triangle CDM, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is CM, so the square of the hypotenuse is CM square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to CD square plus MD square. Okay. CM equals to R plus 2. We already found out that CM equals to R plus 2. CD equals to 2 minus R. We already found out that CD equals to 2 minus R. So CD square will be equal to 2 minus R square plus MD square. We open the brackets of equation number 1 and we got that R plus 2 square equals to R square plus 4R and 2 minus r squared equals to 4 plus r squared minus 4r plus md squared. Here we have r squared in both sides of equation number 1, so r squared will get cancelled. And we have also 4 in both sides of equation number 1, so 4 will also get cancelled. And what is left from equation number 1 after we cancel those two expressions, what is left in this side is left only 4r, and the other side, what is left, it is actually minus 4r plus dm squared. Here we added 4r to this equation number 1. 4r plus 4r is 8r, and minus 4r plus 4r is 0. So in total we got that 8r equals to md squared. Here we took a root out of equation number 1, this equation, and we got that md equals to the square root of 8r. We know that 8 is 4 times 2. 8 is 4 times 2, so we substituted 8 by 4 times 2, and we got that md equals to the square root of 4 times 2 times r. The square root of 4 is 2. So we wrote it down, we wrote that md equals to 2 times square root of 2r. So we found out that md equals to 2 times square root of 2r. Here md equals to 2 times square root of 2r, but according to rule number 4, the opposite sides of a rectangle are equal to each other. That is to say, md equals to no. In rectangle MNDO, the opposite sides of a rectangle are equal to each other, according to rule number 4. That is to say, md equals to no. But we have already found out that md equals to 2 times square root of 2r. From this equality, we will get that NO also equals to 2 times square root of 2r. So here, NO equals to 2 times square root of 2r. Okay? Then, we join together points M and O by a straight line. We did the same thing also in the original drawing. We join together points M and O by a straight line, and we join together points AM and M by a straight line. AM is the radius of the small circle, that is to say it equals to R. So AM equals to R. AO is the radius of the semicircle, that is to say it equals to 4R. AO is the radius of the semicircle, that is to say it equals to 4 units. So AO equals to 4 units, AM equals to R. What is the value of MO? From this drawing, you can see that MO equals to AO minus AM. Again, AO minus AM equals to MO. Okay, so MO equals to AO minus AM, but we have already found out that AO equals to 4 units and AM equals to R. So in total we found out that MO equals to 4 minus R. So we can write here that MO equals to 4 minus R. Okay, MO equals to 4 minus R. MN equals to R, and NO equals to 2 times square root of 2R. We focused on the right triangle M and O. In the right triangle M and O, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here, in the right triangle M and O, the green triangle M and O, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is MO. So the square of the hypotenuse is MO square, and it equals to the sum of the squares of the perpendiculars, that is to say it equals to MN square plus NO square. So MN equals to R, and NO equals to 2 times square root of 2R. So NO square is 2 times square root of 2R square, and MN that equals to R. So MN square will be equal to R square. So in total we got that 4 minus R square equals to R square plus 2 times square root of 2R square. We open the brackets on both sides of equation number 2, and we got that 4 minus R square, it is actually 16 plus R square minus 8R, and the square root of 2 times the square of 2 times square root of 2R square, it is 8R. Here we have R square in both sides of equation number 2, so R square will get cancelled. After we cancelled R square, we added 8R to this equation number 2. 16 minus 8R plus 8R is 16. 8R plus 8R is 16R. So in total we got that 16 equals to 16R. 16 equals to 16R. We divided equation number 2 by 16. 16 over 16 is 1. So we found out that the radius of the small circle R equals to 1 unit. So here R equals to 1 unit, R equals to 1 unit, and here CD that equals to 2 minus R, and R equals to 1, so CD equals to 2 minus 1. That is to say CD equals to 1, and here MC that equals to R plus 2, and R equals to 1, so in total MC will be equal to 1 plus 2, that is to say MC equals to 3 units. Okay? And in the next step, we focused on the green right triangle CEY, and we've also focused on the right triangle CDM, and we actually proved that those two right triangles can similar to each other. Why those two right triangles similar to each other? First of all, we have those two angles. Those two angles, they are equal to each other. They are both right angles. So here, angle CY equals to angle CDM equals to 90 degrees. They are both right angles. And we also have this angle that is a common angle. It belongs to both triangles. Therefore, we can write down that angle C equals to angle C. It's a common angle that belongs to both triangles. So angle C equals to angle C is a common angle that belongs to both triangles. And finally, we have those two angles that are also equal to each other according to third angle theorem. What is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. Here we have, this is the first pair of angles that congruent to each other. They are both right angles. This is the second pair of angles that congruent to each other. This angle equals to itself. So we have here in those two triangles, two pairs of angles that congruent to each other. Therefore, according to third angle theorem, then the third pair of angles must also congruent. That is to say, those two angles must be equal to each other. That is to say, angle CYE equals to angle CMD. Okay, angle CYE equals to angle CMD according to third angle theorem. So we actually proved that all three angles, 1, 2, 3, of the right green triangle CEY equals to all three angles, 1, 2, 3 in triangle CDM. Therefore, we proved that those two triangles are similar to each other according to angle similarity rule. Okay? We actually proved the triangle CY is similar. This is the sign of similar. Triangle CYE is similar to triangle CDM according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle can go into all three angles in another triangle, then you actually prove that those two triangles are similar to each other according to angle similarity rule. And from the fact that triangle CYE is similar to triangle CDM, we will conclude that CE over CY in the green triangle equals to CD over CM in the right triangle CDM. Okay, CE over CY equals to CD over CM. So C over CY. CY is the radius of the middle circle, that is to say it equals to 2 units. You can see here that CY is the radius of the middle circle, therefore it equals to 2 units. So CY equals to 2 units. CD, you can see from here that CD equals to 1 unit. And here CM equals to 3 units. Okay, CM equals to 3 units. So in total we found out that CE over 2 equals to 1 over 3. We multiplied equation number 3 by 2 and we found out that CE equals to 2/3. CE equals to 2/3. Here CE equals to 2/3. And what is the value of DE? DE equals to CD minus CE. Okay? DE equals to CD minus DE. But we already found out that CD equals to 1 and CE equals to 2/3. So in total we found out that DE equals to 1 minus 2/3. That is to say DE equals to 1/3. So we found out that DE equals to 1/3. And what is the value of OE? OE equals to OD plus DE. OE equals to OD plus DE. So OD equals to 1 and DE equals to 1/3. OD equals to 1, D equals to 1/3. So OE equals to 1 plus 1/3. 1 plus 1/3 is 4/3. So OE equals to 4 over 3. So we found out that OE equals to 4 over 3 units. Okay. Then I presented to you rule number 5, that the sum of the angles on one side of a straight line equals to 180 degrees. And we wanted to find out the size of this angle OEB. And we have OC, here OC is the radius of the middle circle, therefore it is absolutely a straight line. Okay, OC is a straight line, so if we focus on this side of the straight line OC at point E, the sum of the angles at point E must be equal to 180 degrees. Which angles we have at point E? And this side of point E we have this angle that is 90 degrees plus angle OEB. The sum of those two angles must be equal to 180 degrees. That is to say 90 degrees plus the size of angle OEB must be equal to 180 degrees according to rule number 5. We've subtracted 90 degrees from this equality and we got that angle OEB equals to 90 degrees. That is to say angle OEB, this angle is a right angle. And if angle OEB is a right angle, then triangle OEB is a right triangle. So I copied again the right triangle, triangle OEB. We know that we have already found out that OE equals to 4 over 3 units. OB is the radius of the semicircle, that is to say it equals to 4 units. And we have to find out only the size of EB. We will find out the size of length of side EB according to the Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say OB squared equals to EB squared plus OE squared. OB equals to 4, so OB squared will be equal to 4 squared. 4 squared is 16. That equals to EB squared plus OE squared. OE equals to 4 over 3 units. So OE squared will be equal to 4 over 3 squared. So in total we got that 16 equals to EB squared, and 4 over 3 squared equals to 16 over 9. So we got that 16 equals to EB squared plus 16 over 9. We subtracted 16 over 9 from this equation number 4, and we got that 16 minus 16 over 9 equals to EB squared. We multiplied 16 by 9 and then we divided it by 9 in order to have a common factor with 16 over 9. In total we found out that 16 times 9 minus 16 over 9 equals to EB squared. 16 times 9 minus 16 is 16 times 8. So in total we got that 16 times, in total we got that 16 times 9, 16 times 9 of 16 times 8 over 9 equals to EB squared. 16 times 8 over 9 equals to EB squared. You know that 16 is 2 times 8, so we substituted 16 by 2 times 8, and we got that 2 times 8 times 8 over 9 equals to EB squared. We took a root out of this equation number 4, and we got that EB equals to the square root of 2 times 8 over 9. The square root of 8 times 8 is 8, and the square root of 9 is 3. So in total we got that EB equals to 8 over 3 times square root of 2 units. Okay? Then I presented to you rule number 6. Actually, we proved that those two right triangles can go into each other. I copied again those two right triangles, and we proved that they can go into each other. Why they can go into each other? Because OA equals to OB equals to 4 units. Those hypotenuses are equal to each other. OE equals to OE. OE is the current side that belongs to both triangles, so OE equals to OE. So by proving those two things, we proved that those two triangles can go into each other. That is to say, triangle OEA can go into triangle OEB according to rule number 6. What is rule number 6? Rule number 6 states that if the hypotenuse and the perpendicular in one right triangle can go into to the hypotenuse and the perpendicular in another right triangle, then the two right triangles can go into each other. And we actually proved that the hypotenuse OB and the perpendicular OE in the right triangle OEA can go into the hypotenuse OB and the perpendicular OE in the right triangle OEB. Therefore we proved that those two right triangles can go into each other according to rule number 6. And from the fact that those two right triangles can go into each other, we will conclude that AE equals to EB. AE equals to EB. Why AE equals to EB? AE equals to EB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides will be equal to each other. That is to say, AE will be equal to EB. And what is the value of AB? AB equals to AE plus EB. AB equals to AE plus EB, but we have already found out that AE equals to EB, so we can substitute AE in this equality by EB, and we substituted AB by AE, and we got that AB equals to EB plus EB. That is to say, AB equals to 2 times EB. But we have already found out that EB equals to 8 over 3 times square root of 2 units. So in total we got that AB equals to 2 times 8 over 3 times square root of 2. 2 times 8 is 16. And in total we got that AB equals to 16 over 3 times square root of 2 units. Or in terms of numbers, AB equals to 7.54 units. I will repeat again. AB, the length of chord AB equals to either 16 over 3 times square root of 2 units, or in terms of numbers, the length of chord AB equals to 7.54 units. Okay, thank you very much.